Welcome friends, so in this one I'm going to show you how to find every derivative of the form derivative with respect to x of ln of ax. A is some constant like 2 or 1/2. So before we write the rule down, let's just go through a couple differentiation processes and then the rule will make more sense. So the first example, okay, imagine you have to differentiate with respect to x ln of, for example, 2x. So you have to make an observation here. Observation is ln is the outside function, 2x is the inside function. So you can use the chain rule as an example. In other words, you would have this. The derivative of the outside would be 1 over, and the inside is the 2x. So that's going to come down here. And then you have to multiply by the derivative of the inside, like this, which would be here the derivative of the 2x that you see. So that would look like this, 2x. All right, then you work through this carefully. So this is 1 over 2x that stays, but then this differentiates into 2. And now when you look at these, you see, hopefully, that this 2 can be cancelled with this 2 right here. Those cancel off. And therefore, all that remains at the very end is 1 over x. Okay, so that's the first thing. Let me just pick up my chalk 1 second here. I'm back. I don't want to step on it. And crush it. All right, so let's look at the next one now. So, okay, second example. Imagine you differentiate with respect to x, and let's say ln of 1/2 of x this way. So let's see what happens here. Let's go through the process. So again, the derivative of the outside is 1 over the inside part here. So it's going to be 1 over 1/2 x. And then you multiply by the derivative of the inside. So that would be the derivative with respect to x of this 1/2 x, like this. So 1/2 x. And then you differentiate 1/2 x. That's just 1/2. That's the derivative of 1/2 x, 1/2. So you're going to end up here, in other words, with 1 over, let's see, we had here 1/2 x times 1/2, you see? But notice, this is a half here, this is a half here, so same thing will happen as before. In other words, whatever this is, it crosses off with whatever that is. And again, you just end up with 1 over x, right? So look, 1 over x comes out, 1 over x has come out again. So is there a rule? Maybe you want to pause the video, maybe you want to write the rule down, but let's do this in some more symbolic form, okay? So I'll do that in blue. All right, so step 3. You're going to differentiate with respect to x. Let's see, ln of ax. So the a is just some constant now. Up here it's a half, then a 2, whatever. It's just some number. So you're going to have the following then. By the chain rule is going to be 1 over ax. So the derivative of the outside, 1 over ax, then you put the inside here, and then you multiply the derivative by the derivative of the inside. So the derivative with respect to x of ax, like that. But because you're differentiating with respect to x, the a is like a constant. Like up here was equal to 1/2, up here it's equal to 2, and so on, in specific concrete examples. So then you continue with this process. You're going to have 1 over ax. And then the only thing left over from this part differentiated right here is the a. That's it. So you're going to have times a. But notice there's now an a in the denominator. There's an a up here. So what can you do with those a's? Well, you can cross them off. Same value, so you cross it off. And therefore, at the very end, all that is left over, as you can see, is just 1 over x. So the rule here is, despite this a being present here, you still just end up with 1 over x as the derivative in general. All right, so I hope it's been helpful and interesting. Please leave a like, please subscribe. Thank you so much for watching. I will see you in another video.